In today's notes, I'm going to look at solving logarithmic and exponential word problems using a graphing calculator. If you think back to the notes that we've been doing, we've only been using a scientific calculator. The scientific calculator, although it works, is kind of difficult because you have to remember to use order of operations, which is PEMDAS, in order to find your correct answer. You can have a lot of errors when you're using a scientific calculator compared with using a graphing calculator. So in this video, I'm going to use the TI Nspire. So if you don't have the Nspire next to you, go ahead and pause the video and get that calculator. Okay, we're going to go ahead and write out a few equations before I actually start with question number 1. And this is just supposed to refresh your memory as to what we did with these word problems in the past couple of pages. So the first equation that I'm going to write out is A equals P ERT, let me make that an exponent, RT, and this is when you have a continuous interest. Another formula that we've used is A is going to equal P times 1 plus R over N to the NT power. This is called your compound interest. And that's whenever it says it's compounded monthly or compounded bi-weekly, something like that. And then the last formula that we saw was A of t is going to equal A sub 0, 1 plus or minus R to the t power. This is called your simple interest. Hopefully I spelled that right. This is called your simple interest. Whenever you're looking at these different equations, you're probably like, Ms. Tapia, this looks a little different from what we've been using. If you look back through your notes, they might not be the exact same, but they still represent the same pieces. For instance, for simple interest, another formula I gave you guys, you don't have to write this out, was f of t is going to equal A, 1 plus r to the t power, plus or minus r to the t power. It still is doing the exact same thing for this formula. The only difference is I just switched the letters around. This A sub 0 is the initial amount. That's what it means for A sub 0. And A of t just means you're finding that time for this A function. So for all of these formulas, we have seen them before. The variables might be a little different, but they represent the same items. So let's go ahead and look at the first question. And this is talking about Seth's parents. So in this question, it says, Seth's parents gave him $5,000 to invest for his 16th birthday. He is considering 3 investment options. Option A will pay him 4.5% compounded annually. Option B will pay him 4.6% compounded quarterly. And option C will pay him 4.4% compounded continuously. If he plans to use the money after he graduates from college in 6 years, determine how much more money the best option will make compared to the other options. Okay, so let's think about this. If we want to compare all 3 options, I need to identify what is the value for option A, B, and C that Seth would have invested with that $5,000. So in this problem, I'm going to zoom in over here, and I'm going to first find option A. So the equation and the answer for option A. In option A, he has 4.5% that's compounded annually. That means every 12 months, he's going to get more interest. He's going to get 4.5% interest. What I'm going to do over here really quick is I'm going to change that 4.5% into a decimal, which means it'll be 4.5. I need to move it 2 units to the right. So this will be 0.045. This is my rate. And then since it says it's compounded annually, a lot of students will say, oh, well, it says compounded. This says compound. We can use this equation. You're not wrong. You definitely can use it. But the issue I have is that it's going to be a lot of extra work. So I'd rather use compound interest when it says like something like monthly or biweekly. Anytime you see something that's compounded annually, your brain should think of a simple interest formula. Simple interest formulas are a lot quicker to solve and a lot easier to solve in my mind. So I'm going to recopy this formula for option A, and I'm going to plug in my values. So A of t is going to equal A sub 0, 1 plus or minus r to the t power. If we read this question, especially since it says he's investing this money, I mean, the stock market is crazy, guys, but it's assumed that that money should increase. So instead of putting that plus or minus, I'm just going to use the positive symbol here. I'm only going to use the positive. The negative would be any type of exponential decay, which means it would be going down. So we're going to rewrite this as a of t, because I don't know what that total is. A sub 0, if you think back to your notes, that's your initial amount. Your initial amount is this $5,000 that he's investing. I'm going to do 1 plus, because we said this should be a positive thing. You're investing it. It should be going up. My rate is 0.045, and I'm just going to keep it to the t power for now. I want you to at least see what this equation looks like without plugging in your time. When is Seth going to use this money? If you think back to the problem, it specifically says he wants to use it after he graduates in 6 years. So I'm going to take my t value and I'm going to substitute it in. A of 6 is going to equal 5,000, 1 plus 0.045 to the 6th power. This is what we're going to plug into our calculator. So I'm going to bring my calculator over, and I'm literally going to plug in all of this. So I'm going to have A of 6 is going to equal. So I'm just getting my answer part ready. So in my calculator, I'm going to kind of refresh your memory with a few things in case you forgot. When you're looking at questions like this, I want you to keep in mind this area here that I'm kind of circling. This is like a touchpad, I guess, that you would say, like in the center of your computer. It is very light to the touch. If you like graze your hand over it, it will move it like a regular mouse. So I personally don't like using this as a mouse. I just like using the 4 corners because it'll actually get where I want to go a lot quicker. With the mouse, it's kind of hiccupy and tricky every once in a while, where it'll kind of glitch every once in a while. So to make it easier on you, we're going to go into a new document. So I'm going to scroll over and hit enter for new. And I only want the calculator because I want to calculate how much Seth's parents are going to help him invest in the next 6 years. So the information I had on the other page, which should be on yours, I'm going to plug it into my calculator. Pay attention with my mouse and the red buttons so that way you know what to plug in. We're going to plug in 5,000. I'm going to put a parentheses. 1 plus 0.045. You don't have to put a 0 in front of this. It'll still calculate your answer. I'm going to close the parentheses and then raise this to the 6th power. So this little caret button right here, it's going to create a little box for your exponent. We're going to type 6 and hit enter. This is how much money I will have, or Seth will have. I'm trying to take his money already. $6,511, and we'll say 30 cents. I'm going to move this out of the way. And that's what I got for my first one. That's for A. Let's look at B. In B, it says he will pay they will pay, so I guess the bank will pay 4.6% compounded quarterly. Okay, 4.6%, I'm going to move that up here. 4.6, if I move that over 2 units, that's going to give me 0.046 for my rate. And then since this is quarterly, I definitely want to use the compound interest, which was the second formula here. I definitely want to use this. And for the compound interest, the compounded quarterly is your N value, not the time. Time is still 6 years, but the compounded part, that's your N value. How often are we going to add money to this account? So I'm going to take the information I labeled over here, and I'm going to substitute it in. So A equals P, 1, let's try this again, 1 plus R over N to the NT power. So A is going to equal P, which is your principal, it's your initial amount, so that's 5,000. 1 plus my rate, which is 0.046, divided by N, which is 4. And we're going to raise it to the 4 times 6 power, because remember, T is still that 6 years. We still want to calculate after he graduates in 6 years, how much money will he have. Well, this one's going to be fun. We have a fraction now. So over here in my calculator, I'm going to bring this back over, and I'm going to substitute this in. Let's see what I'm going to get. So I'm going to plug in 5,000, and I'm going to put parentheses, 1 plus, I had a fraction on my paper, and if you don't believe me, look back at your paper, and you should have a fraction, 0.046 divided by 4. If you look closely, so if you need to, pause the video and look, but right above this division symbol in blue, we have a fraction. Hit Control, and then division symbol, it will pop up with an actual fraction. That's when we're going to plug in our 0.046, and we'll divide it by 4. This makes my life so much easier, guys. By having that actual fraction button, you can actually get a lot more things done. I'm going to scroll all the way out of this parentheses and then raise it to the 4 times 6 power. I know that it's 24, but I'm still going to be lazy and put 4 times 6. Once you have that typed in, hit enter. That's my value, 6,578.87. Let me move that out of the way. So I'm going to make my A value here, let me write this in pen, is going to equal 6578.87. For part C, this one, let me zoom out just a bit, is option C is for a continuous or compounded continuously. Compounded continuously is that continuous interest that we have here. That's what we're going to use. So the only thing I really need to do is rewrite this 4.4 as a decimal. So 4.4 as a decimal. Let me show you how to do that in your calculator just in case. So in your calculator, you can type in 4.4 and divide it by 100. The only reason why I'm showing you this is to show you how to use your calculator. And we're going to get 0.044. And that is my rate. So let me move this over. You guys, take this information, what we have here, the $5,000, that's our principal, the rate, which is 0.044, excuse me, and plug it into this formula. If you're brave, try plugging it in your calculator as well. So in this problem, I'm going to have A equals P, which is the principal. That's 5,000, not 1. We're going to use E to the RT power. R is the 0.044, and T is the 6. That's the time. And I could have written these like I did here with just leaving the time as it is just to show you what it looks like, but I guess I got it kind of lazy. All right, let's go ahead and plug these things in. So in my calculator, I'm going to take all of this and I'm going to plug it in. So we're going to take 5,000. E is right here. It gives you an E, and that little X means you're going to have some kind of exponent. Next thing I'm going to do is I'm going to take 0.4044 and I'm going to multiply it by 6. This is going to give me, A is going to equal, and I'm writing this on my paper so that way you guys can see it when I move it, 6510.64. That's my answer. All right, so I have all 3 of these. We did all this work. I honestly kind of forgot what we were looking for, so let me look back at my problem. The problem specifically says, how much more money is the best option? How much will it make compared to your other options? Okay, well, let's see. You guys look, which one's the best option for him to pick? Hopefully you're saying option B. So down here, I'm going to say option B is the best because we need to know how much more money it will make compared to the other plans. Okay, so using your calculator, now that you know how to use the basic functions, take the option B and let's compare it to option A. How much more money will you get if you use option B over option A? So what I mean by that is subtract both of these values. What are you going to get? Hopefully you got 67.57, so $67.57. That's how much more money you're going to get from option A, because it will earn 67.50, ooh, not 57, 8, yeah, no, 57, ooh, $57 more than option A. And how much more money will you get if you use option B over option C? So subtract both of these numbers now. I will tell you, if you're not practicing this and plugging it in your calculator, I can't help you on tests and quizzes. It will earn, in this case, it's going to earn $68.23 more than option C. Excuse the horrible handwriting, but this should be your answer. Option B is the best option because it'll earn $67 more than option A and $68 more than option C. So make sure you have that piece added in. All right, let's look at number 2. For number 2, it says, in New York State, the minimum wage has grown exponentially. In 1966, the minimum wage is $1.25 per hour, and in 2015, it is $8.75 per hour. Algebraically, determine the rate of growth to the nearest percent, so the nearest whole percent when you see that. Okay, let's think about it. How am I going to find this? Okay, let me look at the options it gave me. It says that it's growing exponentially, so growing means it's probably going to be some type of growth since it'll be likely increasing. It's going to go from 1966, it'll start at $1.25. 2015, it'll get to $8.75. We need to find the rate of growth. So I'm telling you now, we don't know what that R value is. Okay, well, think about it. What do we have? We're given a bunch of don'ts, but we do actually have a lot of things. Remember how I said in 1966, you're starting out at $1.25? That's your initial amount. So I'm going to write this, and actually, before I write that, we need to also identify which formula we're going to use. Okay, we didn't see anything about compounding continuously, so any monthly or anything like that, continuous interest, we don't have that for, okay, I'm mixing these together. Let's try this again. We didn't see anything about compounding continuously. That's this first one, so that one's out. We also didn't see anything about compounding monthly, bi-weekly, weekly even, so we can't use the middle one. We're only left with the simple interest. So let's try to see if this simple interest formula is going to work. So I'm going to recopy it down here. A of t is going to equal a sub 0. I always want to subtract it or add it. 1 plus my rate raised to the t power. Since it says that it's grown, that's why I put that plus symbol. Okay, so my initial amount, which was what we're starting with in 1966, that's my a sub 0. So a sub 0 is 1.25. I don't know the rate, so R is a question mark. Oh, I think I can find my time. If we go from 1966 to 2015, how much time is that? And I'm going to write all of these pieces out while you guys are calculating. In your calculator, do 2015 minus 1966. Hopefully, you saw that going from 1966 to 2015 is going to be 49 years. If you didn't write this stuff down, go ahead and pause the video or just keep writing. I'll wait. If I have all of these pieces, I need to know what the rate is because that's the problem. That means I need to use A of t somehow. A of t is like your final amount. Okay, well, especially since this is going to keep going, it's not going to necessarily stop here, but I do know that in 2015, I had $8.75. We already used the 2015 when we found the time, so let me use the $8.75 for my A of t. In 2015, that will give me $8.75. So my A of t, which is the final amount just for this year that we're looking at, it'll be $8.75. So let's take all of this information and plug it in. So I'm going to have 8.75 is going to equal $1.25, 1 plus my rate, because I don't know what that is, raised to the 49th power. All right, let's solve. Okay, to solve this, I need to isolate everything and get it away from my R. So to get everything away from my R, I have to move this $1.25 first. So I'm going to divide both sides by 125. So in my calculator, I'm going to do this off screen at first, and when I need to show you guys something important, I'll definitely pull it over. So 8.75 divided by 1.25, that'll give me 7, and that's going to equal 1 plus R raised to the 49th power. Okay, think about this before we start doing anything else. If I had 7 equals 1 plus R squared, what's the opposite of squaring something? Well, the opposite of squaring something is to square root, both sides. Well, it's the same thing here. This is a 49. Well, I can't do the square root on both sides, but I could do the inverse operation, which is to do the radical but make that index, which is a little number that sits on top, a 49. And move this equal sign over. Equal sign. And I'm going to make this my radical with the 49 for my index because I want you to see that 49. When you have an index with a radical and an exponent of the same value, these are going to cancel. So when you square root something that's already being squared, same logic. So we're going to take the 49th root of 7. So I'm going to move my calculator over because you definitely want to know how to do this. In blue, right up here above that little caret symbol, so look at your calculator, we have n radical x's underneath them. It's really hard to see from here. So I'm going to hit Control, the caret symbol, and I can type in the 49th radical root of, scroll over, not down, scroll over, and get into 7. That's going to give me this big ugly decimal, 1.04051. I'm going to keep that decimal here because actually if you scroll up, and you don't have to do this, but look at what I'm doing. If I scroll up, hit enter, one thing, it copies it down, but it also adds in a lot more decimal places behind it. I'm probably going to need this soon. So let me look back at my notes, and I have the value that I just found, 1.04, and I have it equal to now 1 plus r. Well, to get r by myself, I'm just going to subtract 1 on each side. So I'm going to make this in my calculator. I'm going to scroll up, hit enter, and then subtract 1. So scroll up, enter once it's highlighted in blue, and then subtract 1. So it's going to give me 0.04, and that's 0.512 equals my r. And then remember, we want to get this into a percentage. Well, in order to get this into a percentage, I'm going to have to multiply this number over here by 100. Because as of right now, it's not moving it's already moved 2 decimal places to the left. I need to move it back 2 units to the right. So over here to the side, I'm going to make this r equals that 0.040512 times 100 to give me my percentage. Let me pull over my calculator one more time. I'm going to scroll up, highlight that value, hit enter, and then just multiply it by 100. I always tell my pre-cal students, all of my students, wait until the end of the problem before you round. Do not do it in the middle of the problem. You're going to definitely want to adhere to that when you get into pre-cal. So over here, my rate is 4.0511. If I look at the directions, it specifically says to the nearest percent. So the nearest percent is like the nearest whole number. So my rate here is 4%, and this is 4% growth. That's my answer. Remember, this will help you so much when you get into pre-cal. Wait until the end of the problem before you round. All right, let's look at the next question. For this next question, it says, if Tanisha has $100 to invest at 8% interest, how long will it be before she has $150 if it is compounded monthly? Okay, so for that compounded monthly, that's a compound interest because it's happening only at a certain time each year, or certain time every year. So I'm going to use this equation here to find my answer. So I'm going to recopy this down here. And when I recopy it, I'm not going to plug anything in just yet. Let me pick a different color. So we're going to have A equals P 1 plus R over N to the NT power. Okay, over here, I'm going to kind of do this to the side. I'm going to label my A, P, R, N, and T. Always try to label these out so you have them in one location. Okay, A is the total amount. Okay, let me reread this. She has $100. It's invested at 8% interest. How long will it take for her to get $150 if it's compounded monthly? Okay, well, I'm looking for the final amount. Well, the final amount I'm looking for is to get to $150. P is your principal amount. Principal amount is the same as your initial amount, so it's going to be $100. R is your rate, so this is going to be 8%, which is going to be rewritten as 0.08. N is how many times it's compounding, so it's compounding monthly, so that's going to be 12 times in a year. And then T is the time. Well, the question says how long, so that's what I'm trying to find. What's my T? Using the information we have, let's go ahead and plug everything in. Let's substitute it. My rate is 0.08 over 12 to the 12 times T power. This is what I need to solve. Okay, so let's think back. How am I going to isolate everything to get t by itself? Keep in mind, this is just a big exponential function. This is your base, this is your exponent. Well, in order to get everything away from this exponential function, I'm going to have to get rid of this 100 first. So I'm going to divide this side by 100 and this side by 100. Okay, those can cancel. 150 or 15 divided by 10, that can reduce. Let me use my calculator. 15 divided by 10 is going to give me 3 over 2. I will let you know you can write this as a decimal, so make sure this is written in your calculator. To write this in decimal form, we can write it as hit menu, scroll down to number 2, which is number, and then scroll down to where it says decimal, which is just the first option. So option 1, hit enter. It's going to say you want to change your answer to a decimal. Yes, I do. It's just going to be 1.5. You can either leave it as 3 over 2 or write it as 1.5. It won't make a difference. It's just up to you. These cancel, so that's leaving me with 1 plus 0.08 over 12 to the 12 times t power. Okay, inside this parentheses, I'm going to go ahead and add. So I'm going to do this off camera. So we're going to do 1 plus that fraction. So use that fancy fraction button that I just showed you. Control division symbol, 0.08, and we're going to divide it by 12. This is going to give me 1.5 equals 1.00667 raised to the 12 times t power. This 1.00667 can actually be rewritten as a fraction. There's methods to my madness, guys, so pay attention. I'm going to scroll back up and highlight it, copy it down, and I'm going to change this into a fraction. You'll thank me later. Menu, scroll down to number 2. We're going to change this into a fraction. Fraction for this is going to turn into 151 over 50. 150. And this is going to be raised to the 12 times t power. The reason why I'm doing this is because I need to figure out how to get t by itself. Remember, this is an exponential function. Let me actually rewrite this a little neater. I need to have somehow this t come to the front. I want to be able to have it where it's on the same level as your regular 150 over or 151 over 50. The way that we do that, if you think back to what we did not too long ago, we took the log base this on both sides. So log base 151 over 150 on the left-hand side, and then log base 151 over 150 on the other side. What that does, if you think back, it will cancel this out, which is going to make my somewhat answer log base 151 over 150 of 1.5 equal to 12t. Well, I'm almost done. I will need to get rid of that 12 in a second, but let me take that log base 151 over 150 of 1.5 to find out what that's going to look like. So on your calculator, please get this in front of you because this is the whole point of me doing this video. Right now, I want you to hit the control, 10 to the x power, which is log. It says log. Notice that it has a space for your base. If we were using a scientific calculator, you would have to use the change of base formula to find your answer. For this question, you don't have to, and it's awesome. So down here at the base, I'm going to hit my control division symbol to get my fraction up, and I'm going to put 151 over 150. I'm going to do that of, in that parentheses here, 1.5. Or you could write it as 3 over 2. If you do it as 3 over 2, use the control fraction symbol, so control division symbol. This is why I love using this calculator, guys. It allows you to do everything with the least amount of effort. This is going to give me 61.0223 is going to equal to 12t. And then from there, we know we're just going to have to divide by 12. So from here, I'm just going to have to divide by 12. Remember, just like I taught you guys, you can't just take that value that has been rounded and divide it by 12. What you need to do, scroll up, highlight that value, hit enter. Look at all those numbers that are behind it. Take it now and divide it by 12. Wait until the end of the problem before you round. So since this problem on the other page says to round it to the nearest thousandth place, so let me scroll over, nearest thousandth, this is tenth, hundredth, thousandth, so up to the 5. So right over here, I'm going to put t is going to equal 5.085. That's my answer. Guys, the whole point of me doing this is so you understand how to do ugly looking computations just like this. If you're not paying attention and you're not practicing it, I can't help you guys. All right, I have one last question that I want to go over, and that last question is right up here. Often environmentalists will capture an endangered species to a controlled environment where the species can produce offspring and regenerate its population. Suppose 6 American bald eagles are captured and transported to Montana to be set free. Based on experience, the environmentalist model, which is given, where T represents the years. So in this formula, this little T right here, that's what we're looking at for T. First question says, what is the predicted population of the American bald eagle in 20 years? Okay, so 20 years, I need to plug it in for that little T. That little T is your exponent. So I'm going to make this, I'm going to zoom in a bit. I'm going to make this P of 20 is going to equal 500, and we're going to divide it by 1 plus 83.33, and we're going to raise it to the negative 0.6162, and then 20 in that parentheses. So great thing about this calculator is I can do that right over here. Oh, don't forget your e, because it does have to be an exponential or logarithmic type function. So don't forget that e. All right, so I'm going to move this over, and I'm going to take all of what I had, I'm going to substitute it in. The first thing that I am going to use is my fraction button. In the numerator, I'm going to put a simple 500. In the denominator, I'm going to put in that whole piece, 1 plus 83.33. E is right here. We're going to raise it to the negative. You don't have to put that 0. I will. 0.162. If you just put 0.162, it'll still give you the same answer. And then I'm going to put a parentheses 20. If you didn't put the parentheses and you just did times 20, you should still get the same answer. Should be the same. So this is going to give me P of 20 is 117.274. This question says, and I'm going to zoom over just for a bit, this question asks you to find the nearest 10,000th. Okay, if I think back to my basic skills, this is 10th, 100th, 1000th. This is not 10,000th. 10,000th is literally the next decimal place. So over here in my calculator, I'm just going to scroll up, enter to copy it down, and I'm going to recopy this instead. So this whole ugly long decimal, you think I'm crazy, but I'm definitely going to write it. So over here, I'm going to remove that 4, and I'm going to recopy 378660914. I'm getting you ready for pre-cal. In my pre-cal class, I specifically tell my students to write out everything and then round at the end. So P of 20 is going to equal 10th, 100th, 1000th, 10,000th. So I need to round this up to an 8. So we're going to make this 117.2738. That's my answer. Last question. The last question said, when is the population going to be 300? Okay, so if I'm looking at this problem here, P, I'm assuming it should be written, but P represents the population. So I'm telling you guys, P represents the population. So this P of T, I'm going to replace with this 300. I need to find the time because the word when means time. It's a representative of time. So down here, I'm going to rewrite this with my 300. So we're going to have 300 equals 500 over 1 plus 83.33 e raised to the negative 0.162 t power. Remember, you don't need that 0 in front of the decimal. Pause the video now and see if you can solve this. Oh, you gave up so soon? Okay, fine, I'll go through it. Okay, so we're going to put this 300 over 1, and we're going to cross multiply. That's the easiest thing you can do. If you're like, oh, I know what to do from here, okay, you can pause it again. Keep trying. From here, I'm going to cross multiply. So we're going to make this 1 times 500 is just 500. 300 times all of this is going to stay 300 times all of this. I'm not distributing that. And please do not distribute this. 162. Keep messing that up. 0.162 t. Okay, if I want to solve it from here, I'm going to divide both sides by 300. And these cancel, these cancel. I could just leave this as 5 over 3. And I'm actually going to just leave this as 5 over 3 because I feel like it's easier. And that's going to equal, these are gone. This is going to be 1 plus 83.33 e to the negative 0.162 t power. Okay, I technically don't need that parentheses. From here, all of this is considered, well, technically, all of this is considered your exponential function. Since this is being multiplied, I'm not going to divide just yet. I'm going to get rid of the 1 first. So I'm going to subtract 1 on each side. So when I have 5 over 3 minus 1, okay, well, you don't need a calculator for that, guys. Just do 1, which is the same thing as 3 over 3. 5 over 3 minus 3 over 3 is just 2 over 3. And that's going to equal 83.33 e to the negative 0.162 t power. Just like I said before, we do need to divide. So we're going to divide the 83.33 because it's literally stuck next to this e for natural log by multiplication. Divide 83.33. I'll do this in my calculator. So I'm going to take my fraction. I love using the fraction button. Ooh, I didn't want to do that. Anytime you want to delete everything, guys, just hit Control and then delete. It clears everything in that line. So I use my fraction button, and we're going to do 2 over 3. So I'm going to make another fraction for my numerator. 2 over 3. And we're going to divide it by 83.33. That's going to give me 0.008. And that will now equal e raised to the negative 0.162 t power. And I know you can't see what I'm writing, but I just wanted to write that before I moved it. So over here, I have it written down. And now I need to think. I need to get this t by itself. How do I get rid of this e? E represents a natural base. E is a natural base. If I want to do the inverse of e, the inverse of e is the natural log because the base is e. Or you could write it as log base e. I don't care which one you pick, guys. Just pick one. For me, I'm going to use natural log on each side. When you see that natural log for e, it's going to cancel. So I have natural log of 0.008, and that's going to equal negative 0.162 t. So in my calculator, I'm going to go ahead and find the natural log of that decimal. So I'm going to hit the natural log button right up here in blue. Natural log. Great thing about that is you don't need a base because it's understood that the base is e. 0.008. Oops, don't do that. Cardinal sin. Scroll up, hit enter. It copies it down because I was about to miss all of those juicy decimal places. I'm going to rewrite that. Negative 4.824. 82827. Okay, almost got lost. Negative 0.162 t. Scroll back. And then I'll divide both sides by negative 0.162. So t is going to equal. It said at the top to round this to the 10th th, 10th place. So I'm going to divide that and round it to the 10th place. So we're going to take this answer, hit enter, and divide it by negative 0.162. Once you recopy that answer, go ahead and round it to the nearest tenths place. So 29.8. That's my years. Let me actually write that out. Years. That's how many years it'll take for it to get to 300 bald equals. That's your answer, guys, and that's your work. All of the stuff that we just did is meant to help you not only refresh your memory as to what we had what we have previously done, but it's also meant to help you understand how to use your graphing calculator to do literally half the work that you've done in your scientific calculator. All of the questions that are at the bottom of this page, I have the answers posted for these online, so make sure that you take time to attempt these questions before you completely give up and think you know everything. If you have any questions about any of this stuff, guys, make sure you let me know.